They say everything in the universe needs balance. For there to be light, there has to be darkness. And for there to be life, there has to be death. But what's wild is that this balance isn't just some deep idea we talk about. It's actually happening right now inside your body. Millions of your cells are dividing, doing their jobs, and some are even dying. And that's not failure. That's not something going wrong. That's your body functioning exactly the way it's designed to be. Before we go deeper into the details, this short video will show you the visual difference between apoptosis and necrosis. As you watch, notice how apoptosis looks organized and controlled, while the necrosis looks swollen and chaotic. Let's start with apoptosis. If necrosis is an accident, apoptosis is intentional. It's controlled, regulated, and energy dependent. It's like a scheduled demolition, planned and organized. And fun fact, around 50 to 70 billion of cells undergo apoptosis every day in a normal human adult. That's how serious our body is about maintaining balance. One of the most beautiful examples of apoptosis happens before you're even born. When you were a fetus, your hands look like a small puddles. And the reason you have separate fingers today is that the cells between them undergo apoptosis. It literally shaped your body during development. Without it, we would all have webbed fingers and toes. Apoptosis also protects us daily. If a cell develops a severe DNA damage, maybe from a radiation or replication error, the body detects it. Instead of letting the damaged cell multiply and possibly become cancerous, apoptosis eliminates it. It removes cells that are potentially dangerous before they become a bigger problem. Now, let's talk about how it happens. The first pathway is the extrinsic pathway. This starts outside the cell. Death ligands like Fas ligand or trail bind to death receptors on the cell surface. This activates initiator caspases, specifically caspase 8 or 10. This then activates executioner caspases like caspase 3 and 7. Think of it like pressing a self-destruct button from the outside. The second pathway is the intrinsic pathway. This starts from the inside the cell. Triggers include DNA damage, hypoxia, metabolic stress, or endoplasmic reticulum stress. These activate BH3-only proteins, which stimulate BAX and BAK. These cause mitochondrial outer membrane permeabilization, allowing cytochrome C to be released. Cytochrome C binds to APAF1, forming the apoptosome, which activates caspase 9. Caspase 9 then activates caspases 3 and 7. Different starting point, but same ending, controlled cell dismantling. Now let's shift to necrosis. If apoptosis is a scheduled demolition, necrosis is a building collapsing during an earthquake. It's uncontrolled, unregulated, and not energy dependent. It happens because of energy, like trauma, toxins, infections, or lack of oxygen. For example, during a stroke, brain tissue loses oxygen supply. The cells can produce energy and they begin to die through necrosis. In gangrene, tissue dies because of poor blood circulation. In both cases, this is not blood, it's damage response. It's chaotic. Mechanistically, necrosis begins when the plasma membrane gets damaged. The cell can't regulate ions anymore. Sodium and especially calcium rush into the cell. Internal calcium stores release even more calcium. This calcium overload is a central event in necrosis. It activates destructive enzymes like calpains that break down structural proteins. At the same time, lysosomes rupture and release enzymes like cathepsins, which starts digesting the cell from inside. Water enters, the cell swells, and eventually the membrane ruptures. Cellular contents spill out into the surrounding tissue, and this is what triggers inflammation. Unlike apoptosis, necrosis is messy and affects nearby cells. So when we compare the two, the differences are clear. Apoptosis is physiological, necrosis is pathological. Apoptosis requires ATP, necrosis does not. Apoptotic cells shrink, necrotic cells swell. Apoptosis keeps the membrane intact and does not cause inflammation. Necrosis ruptures the membrane and triggers inflammation. And that would be all. See you next time. I hope you learned something today.